Alright, hello math fans. Today we're going to start with compound inequalities. And the first type of compound inequality we're going to talk about is an OR problem. Okay, so it's an OR problem. That is a key word, and the way you know it's an OR problem is you see the word OR in it. Alright, so let's just start out with a real basic example, because this is exactly the way I want you to solve a problem. So I'm going to give you a problem that's really solved already, and we're going to graph it. So x is less than or equal to 3, or x is greater than 5. So if I would graph this on a number line, basically what you do is, here again is the key word there, OR, and you're going to graph two different numbers. So 3, I want one number in between, and we're going to graph that way, and graph that one that way. Now that actually is a solution to this problem. You would not go any farther than this. Now, it's pretty rare that I would give you something that's already solved. But what's going to happen is you're going to have to solve some of these problems, and then you're going to come up with a graph, and that's going to be your answer. So there are going to be two blanks on a quiz or a test. The first blank is actually going to be this blank right here, where you're going to say x is less than or equal to 3, or x is greater than 5, after you solve it. And the second blank is going to be a number line, right there. Okay, so that number line is just the graph of both of those. This is the way an OR problem works. Wherever you see a line, so it's basically wherever you see a line, and wherever you see a line, that is the solution. So for example, I see a line starting here and going out. I mean, I'm just following the line, and I see one starting here and going out. So my solution is everything from here out. So if I would just like shade everything, that's all my solution, and everything from this point out, that's my solution too. This point right here, or this spot right in the middle, is not part of the solution. It's not part of the solution. Okay, so that's why it even says x is less than or equal to 3, or x is greater than 5. But if I said, is 4 a solution? Well, is it less than or equal to 3? No. Is it greater than 5? No. That's why 4 right over here is not part of the solution. Okay, so that's just important that you understand that it's wherever you see a line, where I just drew that red, shading that red in, that's part of the solution. Where you don't see any line, that's not part of the solution. Okay, so let's try another problem here, where you have to do a little bit of work. Alright, so if I have x plus 5 is greater than or equal to 12, or 2x minus 3 is less than or equal to negative 7. So we're going to solve each one of these like normal. Subtract 5 from both sides, so x is greater than or equal to 7. And this one I'm going to add 3 to both sides. And I get 2x is less than or equal to negative 4. Divide both sides by 2. Do you get a negative here? Yes, you do. Do I flip the inequality sign? No, because I did not divide by a negative. This 2x is a positive 2x, so you don't divide by a negative, just divide by positive 2. So we basically get x is less than or equal to negative 2. So there's, even though it's not here, there's an OR in between them. So this is, I don't know what the solution is yet. The only way you know the solution is after you graph it. So let's just say on the side here, here's an answer blank, and then here's a number line. So you did all this work. I'm not going to graph this on the number line yet. I'm going to make a separate number line because I need to see exactly what's going on here. So I have negative 2, 0, and 7. I need 3 numbers on there as always on my number line. Okay, less than or equal to negative 2. and greater than or equal to 7. Okay, so that is my solution. My solution is x is less than or equal to negative 2, right here, because it is this all the way down here. And it's also greater than 7 because it goes up that way. So in the answer blank, you're actually going to write down what you have here. You're basically going to write this guy right down there. So it's going to be, and it doesn't really matter the order. I like to put the lower one first. So x is less than or equal to negative 2, or, and this is a key word, guys, do not forget the word or, otherwise it's wrong. If you just write x is less than or equal to 2, comma, x is greater than or equal to 7, it's wrong. You're going to lose 1 point. So x is less than or equal to negative 2, or x is greater than or equal to 7. So that's the answer you're going to put on the answer blank, and then you're going to graph it just like you did over there. So that and that. That's going to be your answer to the problem. Okay? So I know some of you are asking, Mr. Curvis, why are you graphing here? Why didn't I just graph it right on the number line because I already knew my answer? Well, what happens if I have a problem like this? And again, this is, well, we'll start out with a pretty basic example. X plus 3 is greater than or equal to 5, or x minus 7 is less than or equal to 4. So we solve it. Subtract 3 from both sides. X is greater than or equal to 2. We add 7 to both sides. We get x is less than or equal to 11. Okay, so let's graph it. Once again, I'm going to have an answer blank, and I'm going to have a number line. So we have a 2 here, and 11 here, and we'll put something in the middle here. We'll put like 7. Okay, greater than or equal to 2. So here it is, solid dot with an arrow. And I'm just going to put it above it, less than or equal to 11. Okay, now the question is, where do you see, is there any open gap here? And there's no open gap. That line is shaded. That line is shaded here, all the way down, and it's shaded here, all the way down. So there is no open gap at all. So if every gap is filled, there's no open space at all, and you see a line, which I do. I saw this line, this line right here. I saw that line and that line. I see it everywhere. Anywhere, you can point to any spot on here. Here, here, here. It doesn't matter what point you point to, there's always going to be a line. So if there's a line everywhere, we all know, and if it's everywhere, that means it is all real numbers. And that's what's going to be on this blank. All real numbers. And how do you represent all real numbers? Remember, you represent all real numbers by drawing, obviously, the double bar R on the blank, and then a number line. You're just going to draw something like that. And then it's always nice when you put one value in there just to represent the for the number line. Okay, so two ways an OR problem can turn out, at least what we're concerned with. An OR problem is either going to turn out to be all real numbers, basically when it's pointing towards each other. Okay, if you have a graph that points towards each other, like graphs like that and like that, that's going to be all real numbers. Okay, if you have a graph that points like this, then you're going to actually have the first type of problem we talked about, where x is greater than 5 or x is less than or equal to negative 3, something like that. All right, so really two kinds of problems. Now I know some of you guys have asked in the past, well, what happens if you have a problem that looks like this? Just real quickly, we're not actually going to cover this, but I just want to go over it. If you have x is less or greater than or equal to 3, or x is greater than or x is greater than 5. So if I go ahead and graph that, here's 3, 4, 5, greater than or equal to 3, greater than 5. Remember, the question is, where do you see, where does the line start? Where do you see empty space? I see empty space right here. All here. That's all empty space. So that's not part of it. But where does the line actually start? The line starts right here, and it goes on out. Okay, granted it's got two lines, but I don't care if it has two lines. I am just concerned about where it has one line. So the answer to this problem would actually be, remember the question is, where do you see a line? Well, I see a line starting from 3, so it's going to be x is greater than or equal to 3. That's the solution to this OR problem. We're not really going to cover these kind of problems, but I just wanted to show you one problem where you get one answer as opposed to two different answers. Okay? So again, our problems are either going to be this way, which there's no space at all, there's no gap at all, so this is all real numbers, or it's going to look like this, which means you're going to say, let's say this is 5, 6, 7. You're going to say, oh, x is less than 5 or x is greater than 7. Because there it is. Less than 5, greater than 7. Okay, so that's what you have to look for. Now, obviously, the key to all these problems is you have to know how to solve just a regular inequality. And what is the main thing that you have to remember when you're solving an inequality? The main thing is when you multiply or divide by a negative. So if the variable has a negative in front of it, and you go and divide by it to get rid of the negative, or you multiply to get rid of that negative number, you have to switch around the inequality. That is so important. So let's do a couple examples here. 2 minus x is less than or equal to 4, or 5 is less than 2 minus x. Okay, so we're going to subtract 2 from both sides. Negative x is less than or equal to 2. Divide by negative 1. So see how this has a negative here. If you divide by a negative, which we did, we divide each by negative 1, we flip around the inequality, so we get x is greater than or equal to negative 2. And then this one, remember what I told you, the variable needs to be on the left-hand side. If it's on the right-hand side and you solve it and you get something like 5 is less than x, and you try to graph that, you're not going to graph it right. Okay? So you don't want to have it like that. You want to have x is greater than 5. So what I'm going to do with this one is I'm going to just move this 2 minus x to the other side. 2 minus x. It's pointing to the 5, so it points to the 5. And then I can subtract 2 from both sides. So negative x is greater than 3. Divide both sides by negative 1. X is, now we flip around the inequality. X is less than negative 3. So again, you're not going to put anything in the answer blank until you actually do a practice graph to see what's going on. So we have negative 3. And remember, negative 2 is on this side because negative 3 is more negative. It belongs on the left-hand side. And put one more point here, negative 1. Okay, it's greater than or equal to negative 2, and it's less than negative 3. Okay, there's a gap in there. This is not all real numbers. If it was all completely covered, it would be all real numbers. But there is a gap. So your answer actually is these two values right here. So on the answer blank, you're going to say x is less than negative 3, or x is greater than or equal to negative 2. And then, as a graph, you'll actually just put this graph that we just did here. And again, you're doing this graph first, so you can see if it happens to be all real numbers, then you will just draw a number line on top. But in this case here, the graph looks like that. So this is your answer, and this is your graph. All right, let's try another example here. And we have 2x plus 5 is less than 17, or 5 minus 3x is less than or equal to negative 7. So we're going to subtract 5 from both sides. So you get 2x is less than 12. Divide by 2. x is less than 6. So this one I'm going to subtract 5 from both sides. Negative 3x is less than or equal to negative 12. Divide by negative 3. X is, now remember we divided by negative, so we have to switch around the inequality. So it's greater than or equal to negative 12 over negative 3 is positive 4. Don't write negative 4, it's positive 4. Negative over negative is a positive. Okay, so we're going to do our little sample graph to see what it looks like. We're going to get 4, 5, 6. So it's less than 6, greater than or equal to 4. Okay, do you see a gap in there? I see no gap in there. It is completely shaded in or completely filled in. Right here, goes here, and then here. So it just keeps going and it keeps going here. So it's covered everywhere. So again, if it's covered everywhere, you should know that this problem on your answer blank is going to be all real numbers. And then on a number line, you know that it's going to be just an arrow representing all real numbers. Okay? It's pretty reasonable. Let's try another example. Okay, 3x plus 4 is greater than 13, or negative 1 is greater than 5 plus x. So subtract 4 from both sides. So 3x is greater than 9. Divide by 3. X is greater than 3. Here I'm going to switch it around. X plus 5 is less than negative 1. It's pointing to the x plus 5. So here when I switch around, it points to x plus 5. Subtract 5 from both sides. X is less than negative 6. Okay, make a quick graph. Here's negative 6. Here's 3. Here's 0. X is greater than 3 and less than negative 6. There we go. So that's actually my answer right here. And that's my graph. So again, here's your two blanks. You're going to say x is less than negative 6 or x is greater than 3. And then on the number line, you're going to just write the exact same thing down there. Okay, that's my answer. Okay, one more example, and then we're done. 3 minus parenthesis 3x minus 4 less than or equal to negative 2 parenthesis x minus 3. And this one is 5 minus 3x is greater than negative 4. Okay, so we got a little bit of work here. Follow all the same rules as we did learn back in the day with solving equalities, except your last step needs to be, if you divide or multiply by a negative, you flip the inequality. Otherwise, it's exactly the same. So it's 3. We're going to distribute the negative. Make sure you get it for both terms. So 3 minus 3x plus 12 is less than or equal to, and distribute the negative 2. So it's negative 2x plus 6. Combine like terms. So negative 3x plus 15 less than or equal to negative 2x plus 6. And I'm going to subtract 15 from both sides. So I get negative 3x less than or equal to negative 2x. And that's going to be minus 9. And then add 2x to both sides. So you get negative x is less than or equal to negative 9. Divided by negative 1, x is greater than or equal to 9. So I flip the inequality sign because I divided by a negative. Okay, and this one's a little bit easier, no parentheses. Subtract 5 from both sides, so you get negative 3x is greater than negative 9. Divide by negative 3, x is less than 3. So if I graph this, I have 3, 6, and 9 greater than or equal to 9, less than 3. Okay, is this an all real number problem? No, it's not, because you have a gap. You have a gap right over here. There's a gap in this area right here. That means it's not all real numbers because it doesn't include those numbers. So you're going to write down on the answer blank, x is less than 3, or x is greater than or equal to 9. Again, do not forget this word right here. Do not forget the or. If you forget the or, you're going to lose 1 point. You have to have the or, unless, of course, it's all real numbers. Then you don't have to worry about that. Okay, and then, of course, on your number line, it's going to just be the same thing here. So 3, 6, 9, less than 3, greater than or equal to 9. So this guy right here is an answer, and this guy right here is an answer. All right, so that's how you do an OR problem. That's part of compound inequalities. And the next day we're going to do ands and betweens. But this is it for OR problems. All right? All right, have a good day. Bye, math fans.